Hello guys, welcome back to my channel based on African motives. Still working on engineering science and two past exam papers. So we are having the question that we are going to focus on, which is on electricity. So if you're new to my channel, you can consider subscribing so that you won't miss any of the classes that we shall be having from Mason African motives. Okay, so we are given the first question on 9.1. How does a current behave when the resistors are connected? Okay, 9.11 in series, 9.12 in parallel. Okay, we know that in a series connection, the resistance, that is something like this. So the current actually is going to be the same throughout. Okay, so this one, the current is the same. All right, then in parallel, you'll be having something like this, where you've got something like this. Okay, so as you can see, the current is going to flow, then another one branches here, another one branches there. So in parallel, that is these currents branches. All right, so that is the idea there. Okay, then on 9.2 we are given that a simple DC circuit consisting of a supply voltage 12 volts and a resistor R1, which is equal to 4 ohms, is connected in series with two parallel resistors R2 and R6. R2, which is 6 ohms, and R3, which is 3 ohms. All right, so I actually have to have a circuit diagram. Just to have a diagram, it helps you to understand what you have there. So it's something like this, where you have got a DC circuit like this. Then we have got a resistor which is in series like this. Then it's connected to a parallel network. So you can have a parallel network like this. So later on, it's connected to a parallel network, remember. Then it goes back to its original. Okay, let me just try to do this. All right, something like this. Okay, so this is a simple DC circuit consisting of a voltage which is 12 volts here. So this is your supply, which is 12 volts, and R1, which is 4 ohms, which is connected in series with two parallel. So in series with this, so this but these are in parallel, then together in series. Okay, so R1 is 4 ohms, so this is 4 ohms, which is R1. Then we've got R2, which is 6 ohms, R2, which is 6 ohms, then R3, okay, R3, which is 3 ohms. So this one is 3 ohms, like that. All right, so the question is to calculate now the total resistance of the circuit. Okay, so the total resistance of the circuit is actually an application of what we have here. Okay, let's just write this as 9.21. So what will be the total resistance? Let's start with this R1. This one is a series. Then together these two are in parallel. So take note, if these two are in parallel, you're going to use product over sum to find what? To find the resultant. Okay, so it is going to be R1 plus these two resistors in parallel, which is R2 and R3. So it's product, which is R2 times R3. That is the product, R2 times R3 over the sum. So it's R2 plus R3, like this. That is the sum. Okay, if resistors, two resistors in parallel, you can use product over sum to find the total resistance. Okay, so now let's substitute here. Our RT is going to be R1, which is this R1 is 4 ohms. Okay, so we've got 4 ohms plus, okay, let's just leave this ohm. Let's just write 4. R2 and R3, these are going to multiply together. R2 is 6 and 3. Okay, so we've got 6 times 3, like this. Everything over R2 plus R3, which is the same, 6 and 3, but they are now adding together like this, 6 plus 3. So that is the presentation, guys, that you are supposed to show. All right, so if you are to simplify, this is going to be 4 plus these 2, they are going to give you 2. If you simplify this fraction, you're going to obtain 2. So if you add 4 plus 2, that is 6, which is to give you 6 ohms. All right, So that is your RT, which is the equivalent or the total resistance of the circuit. All right. Then another part is to calculate the current through R2, through the R2 branch on the parallel section. Okay, the current that is going to flow through R2 on the parallel section. Okay, let's see the diagram that we had here. So you see now the advantage of having a diagram. Now you can relate to say, okay, this is the branch that is R2, this one. So remember that you have got the total current actually which is flowing in this. Okay, then we are going to have, okay, let's use this part since these are positive. So let's use this direction. So it's going to be like this. So if this is the total current, here we are going to have the current which is going to flow in this resistor 2. Let's just call this I2 and this one I3. But in order for you to have this current in this resistor which is R2, we must have the total current. There is no way. We need to have the total current of what? Of the circuit, which we know that we can use. Okay, so this is 6 point, is it 6 or 9 now? What am I writing? 9. This is 9.22. Okay, so the first thing that you're supposed to do is to calculate the total current. Okay, so the total current, that is this voltage, the total voltage of the circuit over the total resistance of the circuit. Okay, so we are going to have the total voltage of the circuit over the total resistance. So the total voltage is 12 here. So you've got 12 over the total resistance, the one that we just calculated, which was a 6. So remember the total resistance was 6. So if you divide, you're going to obtain 2, which is measured in amps. Current, remember, current is measured in amps. But this is not our major focus here. We need this to help us to calculate what we need, because now I know that I'm having a current here which flows of 2 amps. And what is going to happen? I know that in a parallel circuit, the voltage is the same here in the parallel circuit. Is the same. So in a parallel circuit, voltage is the same. So I'm going to find the voltage of the parallel circuit so that I can find the current here, because if I have the voltage and the resistance, I can find the current. So how am I going to obtain this voltage of the parallel circuit? I'm going to use the total resistance of the parallel circuit. Okay, so I'm going to find V parallel, which is the current. Remember, it's going to be the total current times the total resistance in the parallel circuit. So the total current is there, which is 2 amps. So it's going to be 2 times the total resistance of the parallels. This one, you can obtain it here. Remember, we were adding, when we added this was actually for the parallel circuit. This was R parallel, which we obtained here. And from this value, we obtained 2. So which means we have the value of R parallel, which is 2. So it's going to be times 2. So 2 times 2, which is 4 volts, like that. All right. So now I know that I have a voltage here of 4 volts, which is across this parallel circuit. There is a parallel voltage here of 4 volts, which is the same. Here I have 4 volts. Here I also have 4 volts, like that. So it's now easier for me to find this current in I2, in resistor 2. Why? I'm going to just use this part now to say, therefore, I2, which is the current in the resistor 2 here, is going to be V parallel over R2. Okay, because the voltage in a parallel circuit is the same. So what is your V parallel? It's 4 over R2, which is R2 in this case is 6. So it's going to be 4 over 6. So these are the stages, guys, that we're supposed to take. Okay, so you have to enjoy this in exam, guys. You have to enjoy it. That's engineering science for you. So 4 divided by 6, you're going to obtain 0.6666666 and so forth. So you can actually round to 3 decimal places, which is 0.123, which is 667, and this is a current measured in amps. All right, so that is what you're going to have in this case on 9.22. So there are so many ways actually that you can use, guys, when you're answering these questions, but for me that was the best way that I could take. 9.3, give one practical application. We need one practical application of mutual inductance. Okay, so where do we apply this? Where do we actually apply mutual inductance? Okay, so I just took this, but remember, I always work with what they give you from the department, so that you don't we don't give answers which are far away. So these are the best answers. We are going to apply this in transformers, induction motor, in the prevention of sudden overloading. So you have to choose any one. Take note, you don't write 3, you choose one from these 3. That is the best answer that you're going to take. So as you can see, these are typical questions. They actually repeat these typical questions, so you must revise along these 3, because sometimes they can ask you to list 3, so you must know all these 3. If they ask you one, then you just select one from that. Okay, so that was it, guys, from this question. As you can see, that's how they ask these questions, and it's 13 marks for that, guys. These are a lot of marks on electricity to lose, which is 13 marks for the whole question there. So it's a matter of revising and working on question paper. So that's it, guys, from Mason African Motives. Till we meet again.